Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as an Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad. So today I would like to give the topic on the one of the important topic in the analytical chemistry, that is quantitative analysis. Okay. So before starting the topic, first of all we see what are the important topics covered in today's section. So first of all, in the quantitative analysis, there are mainly two types of the analysis are involved. That is gravimetric analysis, and second one is called as volumetric analysis or titrometric analysis. Okay, so in any type of the analysis, the analysis is mainly based on the quantity of the sample or quantity of the analyte. So that's why this is called quantitative analysis. So depends upon the type of the sample, that means the physical state of the sample, it will be classified into mainly two types. One is gravimetric analysis and another one is the volumetric analysis. That means the sample is in the form of a solid state, that is solid form, that is called gravimetric analysis, whereas the sample is in the form of liquid, so that is called volumetric analysis. Let us start gravimetric analysis. In the gravimetric analysis, mainly the analysis is done by based on the mass of the substance. Okay, so in this analysis, the compound is to be estimated, it is converted into insoluble compound of known composition. So insoluble compound means nothing but a precipitate. So precipitate means, so precipitate is formed whenever the solubility product of the substance is less than the ionic product of the substance. So at this condition, the insoluble compound is formed. So after the formation of insoluble compound, that compound is separated. Separation can be done by centrifugation, and after that drying will be takes place whether by desiccator mode manually or by using the instrumental mode, oven mode. After that we see weighed. Weighed means weighing takes place by using the simple analytical balance. So these are the mainly steps involved in the gravimetric analysis. So first of all, gravimetric analysis mainly involves the compound is converted into a insoluble compound. Insoluble compound means precipitate, and the condition for the precipitate is required is whenever the solubility product of the substance is less than the ionic product of the water. After that, the compound is separated by using the centrifugate, that means centrifugate mission. After that, it is dried by either instrumental method or oven, and after the resultant compound is weighed by the simple analytical balance. So, and what are the equipments used for this gravimetric analysis? There are mainly totally three types of the equipments used in the gravimetric analysis. The first one is the desiccator, and second one is the crucible tanks, and third one is the crucibles. Okay, so first one desiccator. See in the picture. In the desiccator, it is mainly useful for to absorb the moisture. That means in the resultant compound, is there any presence of the moisture? So that is absorbed by the calcium chloride substance. At the bottom of the desiccator, there is a substance that is calcium chloride that will be helpful to absorb the moisture present in the sample. And second one is the crucible tongs. So crucible tongs means this is helpful to handle the crucible from the heavy temperatures or from the oven to bench table and from bench table to oven. So this is applicable for the purpose of to handle the sample present in a crucible. And third one is the crucibles. So these are very, very important for the handling of the sample compound and applicable for the purpose of to heat the resultant compound. Okay, so these are the mainly three types of the equipments used for the gravimetric analysis: desiccator, crucible tongs, and crucibles. So after that we see what is the importance of the gravimetric analysis. So gravimetric analysis is the one of the quantitative measurement of the analyte by weighing a pure solid form of the precipitate. So already we discussed about this gravimetric analysis is comes under category of the branch of quantitative analysis because the analysis is mainly depends upon the mass of the substance. Okay, and the resultant compound is in the form of a insoluble compound. Insoluble compound is nothing but a precipitate. Okay, next, gravimetric analysis is one of the most accurate. Accurate is nothing but exact method, and precise method means specific method for the methods of macro quantitative analysis. That means analysis is mainly classified into three types. That is quantitative analysis, macro, semi-micro, after that micro analysis. So out of three analysis, this gravimetric analysis comes under category of the macro quantitative analysis. Okay, why? Because we use the large amount of the substances. So that's why this is called macro. Okay, and next one, often required for the high precision. High precision means it requires the high exactness and high accuracy of the experiment. Next one, obtain pure solids from the solutions containing an unknown amount of the methyl is done by precipitation. So, for example, if you can determine the one of the cationic compound like nickel compounds, so these nickel compounds are obtained from a nickel sulfate solutions. So, from the solutions of a metal ion compounds, we obtain a solid form of a metal. The nickel is the best example for the determination of the nickel compound as a cation from gravimetric analysis. After that, we see gravimetric analysis describes a set of methods used in the analytical chemistry for the quantitative determination of analyte, the ion being analyzed based on its mass. That means analytical chemistry, the chemistry which deals with the both qualitative and quantitative analysis, that is nothing but an analytical chemistry. And in the quantitative analysis, again depends upon the solid state or liquid state of the compound. It will be classified into mainly two types, that is gravimetric analysis and volumetric analysis. Now in the gravimetric analysis, the analysis is in the form of a sample compound, especially in the solid state. So that's why the entire gravimetric analysis is purely depends upon the mass of a compound or mass of a sample. Next one, the principle of this type of the analysis is that once an ion's mass has been determined as a unique compound, that known measurement can then be used to determine the same analyte's mass in the mixer. So as long as relative quantities of the other constituents are known. So that means one is the known compound and another one is the unknown compound. So once you finalize that weight of the compound, that should be unique in the gravimetric analysis. So that is main principle involved in the gravimetric analysis, comes under category of the quantitative analysis. So now we see what are the applications of the gravimetric analysis. So there are several applications for the gravimetric analysis. So especially now we see the gravimetric analysis is applicable for the determination of both the cations and anions, So first of all, we see the gravimetric methods have been developed for most of the inorganic anions and cations. So inorganic anions means like nickel, zinc, all of these comes under category of the for the determination of the cations by gravimetric analysis. Whereas cations, so cations and anions, anions comes under category of the for the determination of the chloride ions, especially in the determination of the precipitation like reactions. So determination of the halogenous compounds. So first of all, these applications of the gravimetric analysis. So gravimetric methods have been developed for most of the inorganic anions and cations. So inorganic anions means like determination of the halogen compounds, chlorides, sulfates, and also bromides, iodines. All of these comes under category of the determination of the anions from gravimetric analysis. And cations means like nickel, zinc. All of these comes under category of the determination of the cations from the gravimetric analysis. So as well as for such neutral species coming from water and sulfur dioxide and carbon dioxide and iodine. All of these comes under category of the determination of the inorganic compounds from the gravimetric analysis. Now we see what are the industrial applications by using the gravimetric analysis. So there are variety of the organic substances especially used for the easily determined and gravimetrically. What are the examples for the in industry determination, especially in the milk industry, for the determination of the one of the carbohydrates, nothing but lactose. So lactose is very very important to give the strength of the babies, especially that very kids, especially very kids, small children. So that's why the lactose is very important in case of the milk. So it is this gravimetric analysis is especially applicable for the determination of the lactose present in the milk, and also in the pharmaceutical industries, especially for the determination of the salicylates in drug preparations, and also in the case of the chemical industries, phenolphthalein present in the laxatives, and also nicotine present in the pesticides. So pesticides is also very important in the pesticides. That nicotine content is very crucial. So that's why it is useful for the determination of the nicotine present in the basic rice, and also cholesterol in cereals, and also benzaldehyde in almond extracts. So this is about the industrial applications by using the gravimetric analysis. Okay, so this is overall explanation for the gravimetric analysis definition, and also the what are the equipments used for the gravimetric analysis, and we discuss about what is the principle used in the gravimetric analysis, and finished with the applications of the gravimetric analysis. Next, we discuss about the volumetric analysis. So this volumetric analysis is also called as titrometric analysis. So this volumetric analysis is also called as a titrometric analysis. Why? Because previously gravimetric analysis is mainly based on the mass of the substance. That means the physical state of the substance is the physical state of the substance is solid form, whereas in a volumetric analysis the physical state of the substance is in the present of a liquid form. So that's why this is called as volumetric analysis. That means the entire analysis of this analysis is mainly based on the volume. So previously the gravimetric analysis based on the mass. Now the current analysis, volumetric analysis, is based on the volumes. So that's why this is called volumetric analysis. And the method used in the volumetric analysis is nothing but a titrometric method. So that's why this is also called as a titrometric analysis. Titrometric analysis. Okay, now coming to the point, in this analysis, the compound is to be estimated is allowed to react with the solution of known concentration, that is the standard solution. So standard solution is nothing but a known strength. Strength of the solution is very, very important in this analysis. So the strength is measured in either molarity, and it is represented by capital M, and second one is normality, and is represented by capital M. Okay, so that strength is present in either molarity or normality. So molarity means the total number of the gram moles of the solute present in a 1 liter of the solution. So that is called molarity, whereas normality is nothing but the total number of gram equivalents of the solute present in a 1 liter of a solution. That is called normality. So, for example, if you can take as any type of the compound, that may be either acid, base, or salt, we can determine that molecular weight and equivalent weight of the substance. So, for example, if you can consider as any acid, base, salt, organic compound, or oxidant or reductant, any type of the compound, by taking an example. So, for example, if you can consider as a sodium carbonate, Na2CO3. Na2CO3, sodium carbonate. So for this sodium carbonate compound, first of all, we determine the molecular weight. So for the molecular weight, first of all, we know about the atomic numbers of the each and individual chemical compound. So in this formula, there are three types of the compounds are exist. So first one, sodium. Sodium means the atomic number is 11, and for carbon is atomic number is 6. For oxygen, atomic number is 8. Okay, now we see the atomic weights. So for sodium, how many? That means 23. And for carbon, 12. For oxygen, 16. Okay, so now we see calculate the molecular weight of the compound. So that means 2 into 23, 46. And carbon, so 1 carbon is present, 12, and also 3 oxygen. That means 3 into 16, 48. Okay, now we calculate the total molecular weight. That means 6 plus 2, 8 plus 8, 16, and 4 plus 1, 5 plus 1, 6 plus 4, 10. Okay. So that means totally it gets 106. So 106 is the molecular weight of the compound. Molecular weight is 106. Now we calculate for the purpose of normality, equivalent weight. Equivalent weight comes under category of equivalent weight is also coming out from a molecular weight. The molecular weight is 106 and equivalent weight coming out from a molecular weight by number of cations or number of anions. So in the given salt, if you observe the 2 moles of sodium plus and CO3 2 minus. So that means there are 2 cations are present or 2 anions are present. So that's why the molecular weight 106 by 2. We get a equivalent weight. So that is exactly 53. So the molecular weight is 106 and equivalent weight is 53. So based on depends upon the weights of the compound, that may be either molecular weight. We prepare the molarity solutions. For molarity, we use the molecular weight, that is called gram molecular weight. GMW. For normality, we use the gram equivalent weight, GEW, gram equivalent weight. Okay, so this is the difference between the gram molecular weight and gram equivalent weight. So the total number of the gram moles of the solute present in 1 liter of the solution, that is called molarity, whereas the total number of the gram equivalents of the solute present in the 1 liter of the solution, that is called normality. So this molarity and normality is used for the strength of the solution. Strength or known concentration of the solution. Okay, so if you know that strength or concentration of the solution, that is called standard solution. Standard solution. So that means standard solution is nothing but a known strength of the solution. So that concentration or strength of the solution is explained in terms of either molarity or normality. Just now we discussed about what is molarity and what is normality by taking one of the chemical substance. And what are the standard solutions examples? In case of the neutralization reactions, the standard solutions for acid is taken as oxalic acid, H2C2O4, whereas for base we can consider as a sodium carbonate, Na2CO3. So these are the primary solutions or standard solutions for the acid base titrations. And coming to the redox reactions. So redox reactions means the reaction takes place both oxidation and reduction. So that is possible by taking either oxidant or reductant. So the primary solutions, that means the standard solutions which are used in the redox solutions are nothing but a potassium dichromate. The formula is K2Cr2O7, potassium dichromate. Whereas in case of complex metric reactions, the primary standards most probably used as a zinc sulfate heptahydrate. Zinc sulfate heptahydrate. And in case of precipitation reactions, sodium chloride is used as a primary standard solutions. So all of these solutions, for example, oxalic acid, sodium carbonate, potassium dichromate, or zinc sulfate heptahydrate, or sodium chloride, all of these comes under category of the standard solutions. So standard solution means known concentration solution, and these are also comes under category of the primary standard solutions. Primary standard solution. That means the concentration of the solution should not be changed with respect to time. So that is called primary standard solutions. And if the concentration of the solutions change with respect to time, so that is called secondary standard solutions. The examples for the secondary standard solutions are sodium hydroxide, and also EDTA, ethylene diamine tetraacetic acid. and also like silver nitrate solution, AgNO3. This comes under category of the secondary standard solutions. Secondary standard solutions, and previously discussed about primary standard solutions. Okay, so this is about the standard solution. So that means standard solution means known concentration or known strength of the solution. Again, these are classified into mainly two types: primary standard solutions or secondary standard solutions. So primary standard solution means the concentration of the solution should not be changed with respect to time. That means they are stable in the presence of the atmosphere. Whereas the secondary standard solutions means the concentration of the solution should be changed with respect to time. That means these are the solutions are unstable in the presence of the atmosphere, that are called secondary standard solutions. Okay, so the standard solutions means known strength of the solution. So for considering a chemical reaction, A and B are reacts with each other to give a product like C. Okay, so out of two reactants, A and B reactants, one is the standard solution. One is standard solution. So that means standard solution means known concentration. By using this known concentration of the solution, we can determine the unknown concentration of another compound. So that is main criteria involved in the Gravimetric analysis or volumetric analysis. Okay, now we see what are the equipments used in the Gravimetric analysis or volumetric analysis. So the first one is called as a suction bulb. So suction bulb means it is called as a pipette, applicable for the to suck the solutions with the help of the rubber bulb. So by using the rubber bulb, because of the we use the so many acids and bases, they are harmful to human beings. So that's why we use the rubber bulb. With the rubber bulb, we sub the solution, and there is a mark. So that is called calibration mark. Calibration mark. So this calibration mark is applicable to know the how much amount of the solution is sucked into the that particular equipment. So in this case, the calibration mark is the calibration mark is different for the both colorful solutions or colorless solutions. Colorful solutions and colorless solutions. So colorful solutions always we consider as a upper meniscus. Okay, so whereas for colorless solutions always you consider as a lower meniscus. Okay, so in this case the solution is colored solution, that's why we consider as a upper meniscus. So upper meniscus means, for example, if it is the mark, we consider as a upper meniscus. So for example, it is a solution, we consider as a upper meniscus. So this is for applicable for the colored solutions, whereas for colorless solutions we consider as a lower meniscus. Lower meniscus. So this is the difference between the upper meniscus and the lower meniscus. This is called upper for color solutions, whereas this is called lower meniscus for colorless solutions. So by taking the solution into the any type of the equipment, that may be either pipette, burette or conical flask, or in the measured flask, we consider the colored solutions or colorless solutions. So for color solution always considered as a upper meniscus, for colorless solutions always considered as a lower meniscus. So this is the difference between the colored solutions and colorless solutions by taking a calibration mark. And second important equipment used in the volumetric analysis is nothing but a beaker. So this beaker is applicable for the purpose of to collect the solution or to transfer the solution from one point to another point. And the third one is the burette. So this burette plays a very important role in case of the titrometric analysis. So this burette is having for accurate volume measuring and titrations. So there is a successive markings, and we measure the even in the range of the 0.1 ml, 0.1 ml. So that is the accuracy of the burette. And fourth equipment is nothing but a conical flask. So conical flask is applicable for the titration method, and also it is applicable to stirring the solution. Stirring purpose. And also the fifth equipment is a graduated flask or volumetric flask. This is applicable for the purpose of to prepare the solutions, for the preparation of the solutions. And there is a stopper is also present for the closing the cap, and there is a calibration mark. So this is applicable for the color solutions and colorless solutions. And at the bottom there is a flat bottom flasks. So that's why this is called graduated volumetric flask. Okay. So now totally there are 5 types of the equipments used in the volumetric analysis. The first one is the suction valve, or it is called as a volumetric pipette. So for the purpose of to take the sample into the conical flask. And the second one is the beaker. Beaker is applicable for the to collect the solution or transfer the solution from one point to another point. And the third one is the burette. Burette is applicable for the purpose of to release the solution into the conical flask by using a 0.1 ml range. And fourth one is the conical flask, which is applicable for the purpose of titration, especially stirring purpose. And fifth one is the graduated flask or volumetric flask, which is applicable for the to prepare the chemical solutions, especially either molarities or normalities in the standard solution. That may be either primary standard or secondary standard solutions, depending on the nature of the substance. Now we see what are the terms used in the volumetric analysis. There are totally 7 terms used in the volumetric analysis. The first one is the titration, and second one is called as a titrate, and third one is titrate, and fourth one is equivalence point or stoichiometric endpoint, and fifth one is the indicator, and sixth one is the endpoint, and seventh one is the titration error. Okay, now we see the terminology used in the volumetric analysis one by one. The first one is the titration. So from the starting of the analysis, we call it as a titrometric analysis or volumetric analysis. Now we see what is the titration. Okay, so titration means titration is the process of adding one solution from the burette to another into the conical flask in order to complete the chemical reaction. So out of the 2 solutions, one must be standard. So standard means in the previous slide we discussed about standard solution means non-concentrated solution or non-strength of the solution, non-concentration or non-strength of the solution. So that means out of the 2 reactants involved in the chemical reaction, one must be known strength. Then only with the help of that known strength of the solution, we can determine the unknown strength of the another compound. And this titration mainly done by using especially 2 main equipments, that is burette and conical flask. Burette and conical flask. Okay, so titration is the process of adding one solution from the burette and another solution into the conical flask. That means while releasing the solution from the burette into the conical flask, the continuous stirring takes place. We can determine the end point of a reaction. Okay, so that is called titrometric analysis. So in order to complete the chemical reaction, and out of the 2 solutions, the condition must be one is non-concentration or non-standard solution. So that is called standard solution. And second one is the titrant. Titrant means the reagent of the non-concentration solution is called titrant. So generally the titrant solutions are taken in the burette. So most probably, most the times the known strength of the solution, that means the standard solutions are taken in a burette. And second one is the titrate. Titrate means the solution is to be determined its strength, that means the reagent being termed as a titrated and titrate or analyte solution. That means this is nothing but a sample compound. So especially these sample compounds are taken in a conical flask. So in the definition 1, terminology 1, we said that the titration is the process takes place in between the solution is released from the burette and collected into the conical flask. Titration will be takes place. So that means the titrant is always taken in the burette and the titrate is always taken in the conical flask. That means the known strength of the compounds, especially taken in the burette, and unknown strength of the solutions is taken in a conical flask, that are called as a sample compound. And fourth one is the equivalence point or end point of a reaction. So that means equivalence point or stoichiometric endpoint of a reaction. So it is the point at which the amounts of the reagent and substance being determined are chemically equivalent, or it is the exact stage at which the chemical reaction involved in the titration is just complete. That means the point at which the reaction is complete, that is called equivalence point or stoichiometric endpoint. So stoichiometric is nothing but a balancing the chemical reaction. That means number of the moles of the reactant should be equal to number of the moles of the products. So for example, if you consider a reaction, A plus B gives rise to C plus D. That means the left side is considered as a reactants and the right side is called as a products. So stoichiometry means number of the moles of the reactants. For example, 1 mole of A reacts with the 1 mole of the B. That means total moles are 2 moles. Where it gives the 1 moles of C, 1 moles of D. That means product moles are 2. So the total number of the moles of the reactants should be equal to the total number of the moles of the products. So that is called stoichiometry, balancing the chemical equation. So in the case of the stoichiometric endpoint is the reaction is just completed. So that is called stoichiometric endpoint. So based on stoichiometric endpoint, we can finalize the required indicator for the any type of the reaction. For example, if you consider the neutralization reaction, in neutralization reaction there are so many indicators are used. For example, in neutralization we use the different types of indicators: phenolphthalein, methyl orange, and third one is methyl red. So all of these comes under category of the neutralization indicators. But out of three, which one is suitable for the required titration? So that should be depends upon the equivalence point of a reaction. So that should be matched with the pH range of the indicator. So for example, if you can take the reaction between strong acid and strong base, strong acid and strong base. So what is the example for strong acid? Hydrochloric acid. And strong base is the sodium hydroxide. So both are reacts with each other to give a neutral products NaCl plus water. NaCl plus water. So it is exactly neutral compound and it is also neutral compound. So that's why this is called neutralization reaction. Okay. So the pH of the reaction, that means the equivalence point of a reaction, it should be nearly at a neutral compound. That means that should be present in the range of a phenolphthalein range indicator. So that means 8.3 to 10. So the equivalence point of the reaction, that means the sodium chloride and water present in the equivalence point range within the range of a 8.3 to 10. So depends upon the matching in between the equivalence point and the pH range of the indicator, we can choose the suitable indicator for the required reaction. So that is the importance of equivalence point. Okay, it is the point at which the amount of the reagent and substance being determined are chemically equivalent. And second definition is it is the exact stage at which chemical reaction involved in the titration is just complete. Okay, and fifth one is the indicator. Indicator is also very important role in case of the titrometric error analysis. Especially, it can visualize the end point of a chemical reaction. Now we see definition. The substance which helps in the visible detection of the completion of a titration is known as a indicator. So indicator is especially applicable for the purpose of the titration done by colorless solutions. Colorless solutions. So previously, by taking the example of strong acid and strong base. Strong acid is hydrochloric acid and strong base is sodium hydroxide. Both are colorless. In case of the colorless reaction, colorless reactants are reacted with each other. We cannot determine the end point of a reaction. So especially in those cases, we use the help of the indicator. So with the help of the indicator, we can determine the end point of a reaction. So for example, in the case of the strong acid and strong base, we consider as a phenolphthalein indicator. So that phenolphthalein indicator shows the color change, colorless to pink. Okay, so from acid to basic medium. So with the help of this phenomena, we can determine a end point of a reaction. So that is the importance of a indicator in case of the neutralization reactions, especially in strong acid and strong base. Indicator, the substance which helps in the visible detection of a completion of the reaction. So that is called indicator. And next, sixth term is the end point. So what is the end point? The point at which the color change of the indicator becomes apparent to the naked eye, that is called end point of a chemical reaction. So that visualization of the completion of a reaction based on the indicator. So such point is called as a end point. That means there are mainly two types of the points are there. One is the equivalence point or stoichiometric end point, and second one is the end point. So these 2 points mainly depends upon the visibility of the naked eye. So that visibility of the naked eye is purely depends upon the indicator, and the difference between these 2 points, that means end point and equivalence point, are called as a titration error. Okay. Now we see what is the definition for the titration error. Ideally, the visible end point and the equivalence point should coincide. But in practice, there is always a difference between the two. The difference is called as a titration error. So, titration error is the difference between equivalence point and end point. So this is the difference between the titration error. Equivalence point and end point. Okay. So ideally these 2 points match with one another, that means equivalence point and end point. But in practice there is a must and should difference in between 2, that is equivalence point and end point. If titration error is more, the percentage of the report is very less. If titration error is less, the percentage of report is high. So that should be depends upon the inversely proportional to each other. Okay. So that means this titration error affects the result of a compound, the result of the analysis. So ideally, the visible endpoint and equivalence point should coincide each other. But in practice, there is a small difference that is called the titration error. So this titration error occurs mainly because an indicator changes in color a little before or after of the equivalence point. So because of this reason, we observe the titration error. So that means the difference between the equivalence point and the end point of a chemical reaction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.